Alright guys, so let's go through these Unit 5 notes real fast, okay? We're almost done reviewing all of GAC 1 so that we can be done with this stuff. Okay, so equilateral triangles means that all sides are equal and all angles are equal. And then what does that look like? Well, it looks like this triangle we call it the perfect we call it the perfect triangle sometimes because it looks so neat and nice. Wow, that was not good. Anyway, all the angles are equal, all the sides are also equal. Okay, isosceles triangle is a pair of equal sides. An isosceles triangle has a pair of equal sides and then a pair of base angles that are equal. So what does that look like? It looks like usually these taller ones where these two angles are equal and these two sides are equal. Scalene triangles have no equal sides or angles. And those just look kind of funky. They don't look like anything specific. That would be a scalene triangle. All right, obtuse means that there is one angle larger than 90 degrees. Okay, so obtuse would look something like this. Okay, this angle being bigger than 90 degrees. An acute triangle has all angles less than 90 degrees. Okay, and that triangle is just going to look like a triangle that you would always see, your more common triangles. Then a right triangle means that there's one 90-degree angle. Okay, and hopefully we know what a right triangle looks like because we've been doing so many Pythagorean theorem questions all year. All right, let's move on to the next part. So it says the interior angles of a triangle always add to 180 degrees. So it says solve for the missing angle. So in order to do this, we would need to add up all of these angles. So it would be 20 plus 90 plus question mark, and that would give you 180 degrees, right? So that's 110 plus question mark, or you could say that's x, is equal to 180. You subtract off the 110 from both sides, and you would get that the last angle is equal to 70 degrees. All right, let's take a look at this other one. A little bit trickier because we aren't given this angle inside of here, but we can see that there's a line that this angle shares, the one that we're looking for, with 130 degrees. So then we can say 130 plus x is equal to 180 degrees because that's how many degrees a line is. We subtract off 130, that gives us x is 50 degrees. So right here, where we have x, we can now replace that with 50 degrees. And then now, what we're doing is we're doing 75 plus question mark plus 50. And then that is equal to 180 degrees. All right, so that's going to be, if we do 50 plus 75, what is that? 30 and then 20, so 125 plus question mark equals 180. Subtract off 125 from both sides, we get question mark is equal to 55 degrees. All right, let's keep rolling. So, base angle theorem. The base angles of an isosceles triangle are always equal to each other. Okay? So, if that's true, then it says solve for x in each of the following triangles using the base angle theorem? Well, this is isosceles. The reason it's isosceles is because both of those sides are equal to each other. So that means this angle would be equal to this angle. So in this case, x is just 46 degrees. In the next one, if we want to solve for the x that's not on the equal angle, again, isosceles because the two sides are the same. We know this angle down here is 47 degrees. So then what we have to do is we have to say 47 plus 47 plus x is equal to 180. So we have to use our old theorem. So then if we're going to take that, what we should do is add the two 47s together. That gives us 93 plus x is equal to 180. We subtract off 93 from both sides, and we would get x. Oops, that is not 93, right? 94, sorry. We subtract off 94 from both sides, and we would get x is equal to 86 degrees. All right, so last one. We know this one is isosceles because these two angles are the same. Because those two angles are the same, then this side would be equal to this side. So what we can do for this question is we set x plus 7 equal to 2x minus 1. So x plus 7 is equal to 2x minus 1. Solve for x, so I'm going to subtract x to the other side. So that gives us 7 is equal to x minus 1. Add the 1 to the other side, and we get 8 is equal to x. All right, next page. So, on the next page, it says 2 important facts about midsegments. A midsegment connects two sides of a triangle. Two sides of a triangle. It is parallel to the third side and is half its length. So it's half the length of the third side. So what we need to look at here. Boom, this is our midsegment right here in the middle. Okay, the midsegment is exactly half of the third segment, so x plus 9. So then there's two ways to look at this. We can either take 2 times the midsegment is equal to the third segment, or you can look at it and you can say 2x minus 3 is equal to half of the third segment. Either way, you're going to solve and get the same thing. The second way, you just have to multiply the 2 to the other side. So in some cases, it looks like an extra step. But this would be 4x minus 6 is equal to x plus 9. On the top, what we would have is we would distribute this 2, and we would get 4x minus 6 equals x plus 9. Okay, so 2 ways to write this problem. 2 ways will get you the same exact answer, though. All right, let's just continue with the top. So if we continue with the top, I would subtract the x to the other side, gives us 3x minus 6 is equal to 9, and then I would add the 6. We would get 3x is equal to, what is that, 15? Divide by 3 from both sides, and we get x is equal to 5. And that's how you would do a mid-segment question. All right, perpendicular bisector, cut a side into 2 congruent pieces at a right angle. So it says solve for x. It's telling us that this is the perpendicular bisector right here. It cut a side into 2 congruent pieces with a right angle. So this piece is congruent to this piece. Okay. Perpendicular bisectors occur inside of isosceles. Yeah, inside of isosceles triangles. So this angle would be equal to this angle, which would then do what? It would make this side equal to this side. So we would have 3x minus 6 is equal to x plus 18. We would subtract the x to the other side. We would get 2x minus 6 is equal to 18. We would add the 6 to the other side. 2x is equal to 24, divide by 2, and we get x is equal to 12. Okay, so perpendicular bisectors occur in isosceles triangles. Okay, all right, angle bisectors. They cut an angle into two congruent pieces, right? So if this is congruent here and this is congruent here, that's what the angle bisector did, because this line right here is our angle bisector. It's also saying that this right here is 90 degrees. I want to make that different color. This right here is 90 degrees, and this right here is 90 degrees. So then that means this angle has to be equal to this angle. Okay, the reason that those two are equal is because all the other angles are equal. Angle-angle theorem for triangles. So what does that mean? It means that this side is then equal to this side, because those two triangles are the exact same. So we'd have x plus 11 is equal to 3x plus 1. So we subtract the x. 11 is equal to 2x plus 1. We subtract off 1. We get 10 is equal to 2x. Divide by 2 from both sides. We get 5 is equal to x. Okay. Next page. It says given point T is the in-center and TW is 15, what does ST equal? What is the in-center? In-center, it's where all the perpendicular bisectors meet. Okay? So let's say that. Where all perpendicular bisectors meet. All right. So notice that if TW, so it's already labeled for us, TW is 15. What is ST? Well, ST and TW are actually the same length. Why? Because if we drew a circle, let's see if I can get this. Oh, that didn't work. Let's see if I can get this to work. If we draw a circle around the in-center, just like this. Oh boy, not smooth enough here. Creates a perfect circle. Notice that the radius of that circle, when we look at TW, is 15. So then the radius ST is also going to be 15. All right, if TU is 4x minus 17, find x. Well, then we look at TU, saying it's 4x minus 17. Okay, well, we know that TU is equal to 15. So we can say 15 is equal to 4x minus 17. We add the 17 to the other side. That gives us 32 is equal to 4x. We divide by 4, and we get x is equal to 8. Next question says, if angle UQT is 30 degrees, so let's find that. Start at U, go to Q, and end at T. So that's this angle right here. That's equal to 30 degrees. It says find angle UQW. So U, different color. So U to Q to W would be this big angle right here, right? TQ is actually bisecting this angle. So TQ is right here. So it bisects this 30 degrees. So then bisect means it cuts it in half. So then what we're going to do is we're going to take 30, multiply it by 2. That would give us 60 degrees. So right here, this angle would be 60 degrees. If the measure of angle SPW is equal to 62 degrees, find the measure of angle SPT, right? So SPW, let's find that one. I'm going to erase some stuff, make it a little bit nicer. So SPW. Oh, I guess I didn't need to. We're on the other side of the triangle. S to P to W. This angle right here is 62 degrees. It's asking us for S to P to T. So SPT then is just this angle. That angle is getting bisected, SPW, so SPW is getting bisected by the line PT. So that means if we take 62 and we divide it by 2, it gives us 31. That tells us that SPT is 31 degrees. All right. Let's take a look at the triangle inequality theorem. So, triangle inequality theorem. In triangle LMN, LM is 14, MN is 18, and LN is 10. So then we can look at this. We can say LM is 14. We can say MN is 8. And then LN is 10. So then let's draw the markings for this. So we'll say L has to be here. L to M is 14, M to N is 8, and LN is 10. Which is the largest angle? So, triangle inequality theorem, one of the facts is that across from the largest angle, or across from the largest side, is the largest angle. So if we go across from the largest side here, 14, that takes us to N. So angle N is the largest angle in this question. It says, write a compound inequality to describe all possible values for X in this picture. Okay. So this question is a little bit harder. We need to consider this as if it possibly could be a right triangle, right? So we could have A here, we could have B here, and we could have C here, right? That's one possibility if this was a right triangle. There's another possibility that we could have A here, B could be 12, and C could be X. So there's two different possibilities here. Either way, in order for it to be a triangle, A plus B has to be greater than C. Or we have another case where A plus B has to be greater than C. This is the only way to make a triangle. So let's do that. Well, if 5 is A and then we add X to it, that would have to be greater than 12. So we subtract 5. And we get X is greater than 7. Okay. Or we have it this other way, where we have A is 5 again. This time, B is 12, and that has to be greater than X. So then 5 plus 12 is 17, has to be greater than X. So then if we look at this, if we rewrote this into a different way, it's saying X has to be smaller than 17, right? Because 17 greater than X is X smaller than 17. And then this says X, if we rewrote this one would say 7 is less than X, right? X greater than 7 means that 7 is less than X. Notice that the arrow is still pointing at the 7 in both of these. So then now it helps us to write it. So we have X, we have 7 less than X. So then we can say 7 less than X. And then we also have X greater than 17. So that's X greater than, and then we can say 17. And that's how you would do that question. All right, and that's all the notes.